So, hi everyone, I'm Nikola Gotsev from Digital Development. I'm a senior solutions developer and a sector. Today I'm going to discuss continuous integration points. By the way, I can do this to sync for the Google Camera, so don't be worried to sync it manually. So when most of the people hear Hedgehog and continuous integration, they think this is just not to get there. And I'm not wanting to focus on this now. There are tons of blog posts out there explaining how to do continuous integration into X using build server Y and things like this. So I want to focus more on the practices you need to follow when implementing continuous integration. To do this, we need to answer the most important question. And it is, what is continuous integration? This is something that we are seeing misconcepted many times. Some people think it's continuous deployment. It's the same. Yeah, it's like how they go hand to hand, but they are basically not the same process. Some people relate that to the source control system they use. With Hedgehog, frequently get the question, I'm using Git, can I use TDS to do continuous integration deployments? So, again, or maybe it's some kind of tool. Some people think that continuous integration can be just achieved with TeamSync and not open contribution. And the simple answer to all these questions is actually no. Continuous integration is not related to the build server you use. It's not related to the source control system you use. Continuous integration is a process and the development practice that you need to use in order to get more stable and quality builds in place. So let's first look into the practice. So the practice is you need to maintain a single source repository, meaning that you can use Git, you can use TFS. If you're more into it, you can use Dropbox or Google Drive, but it's really important to have a single source repository. The second step is automating the build. Meaning that your build should be self-sufficient to execute everything it needs. You don't need to manually package files or items. Your build should be automated out of the box. Making your build self-testing, meaning, again, unit tests. I am going to repeat unit tests multiple times during my presentation, but they are really important for good continuous integration builds. The next step is that every commit should build on an integration machine. So I'm doing something, someone else on my team is doing something, we're both checking it. Not just the final version should build, every checking should build. So it will make it a lot easier to find the wrong build. The practice basically makes it really easy for everyone to get the latest version of the website or the package. So you can just copy your code and paste it. And most importantly, everyone can see what's happening. Even your project managers, your clients, everyone can be notified if the build server has an exception. So the practice is basically securing that your builds are stable and that everyone is aware that they're stable at this moment. And if something goes wrong, your client can escalate, start writing emails with urgent, and things like this. So the next step is the process. So many of you are already familiar with it, so I'm just going to go fast through these slides. So the process is the developer checkouts their code into their local, their box, their private workspace. When they're done, they commit the changes to the repository. So, as we said, we're using a single repository. The CI server then monitors the repository and checks out changes when they occur. So every time you make a check-in, my CI server sees that and checks them out. The next step is the CI server builds the system and runs unit and integration tests. That's probably the most skipped step ever, because let's face it, not many of us are writing unit tests, not to mention integration. Integration tests are usually part of the quality assurance team, not of the development one. After that, the CI server releases deployable artifacts for testing. By testing, I mean validation testing and something that your client can validate that your build was successful. The next step is really important. If the build fail, build or the test fail, the CA server should alert the team, meaning everyone, the project owners, the developers, the team leads, everyone. And the final step is to continue repeating this process to your entire project lifecycle. So let's see some graphs because I like graphics. This is something that explains a normal .NET continuous integration process. Here are the developers. They already have their code. They checking their changes. They are starting to server here. The build server then fetch the changes from there, use them, test them, fail or succeed. No matter what the result is, it should notify the success of the developer and the manager. With SUGCON, the things are a little bit different. We have an extra step here for the following items. Always, you cannot test your continuous integration process without having the building builds. So here is a graphic that can explain a nightly build with SUGCON. For nightly builds, there is actually a different solution. So again, this step is the same. I do my change, I check them, I'm fetching changes, my build server views them, and the next step is a little bit different. So you can use SUGCON sim to automate spawning the new instance, meaning that you can delete your old instance and restore the new instance with SUGCON sim. After that, you deploy your project, meaning your code and templates, layouts, and you can basically get the content from your production environment. After that, you are free to execute your long-running tests, because long-running tests are something that really cripples a good build. The build should always be fast. It shouldn't take like an hour or two, because we can see a lot of these solutions with builds taking hours and hours. So, continuous integration actually tries to solve one of the most common problems. And the most common problem is actually deploying Friday at 5. How many of you are forced to deploy Friday at 5? No? Really? Okay, so I have done this before, and we're really happy we implement our bug tracking system. So every time the server has a server error, it sends an email to the developer. After the Friday deployment, we are really proud of the system because on Monday morning I get like 58 emails just with bug reports and server errors. So continuous integration actually helps us find. Our CTO, Charlie Brown, says that it's always cheaper to find bugs in lower environments, meaning DevOps integration servers, and it's really cheap on DevOps and really expensive in production, meaning that your production bug is actually seen by everybody. One more goal, and we are going to the best part. So, continuous integration doesn't get rid of bugs, but it does make them dramatically easier to find and remove. That's said by Martin Fowler. That's basically the guy who taught this stuff. So, to answer the question, how do I supercharge my CI process? And the first step is always having the continuous integration built in place. So it might seem obvious, but I've seen many servers that just have automated builds, and they don't actually have continuous integration. So they are not building every check-in. Their guys are just committing there, clicking new build, and that's how it works. You always need to have a continuous integration build in place. And shared builds count as well. So your nightly build is also considered a continuous integration. Subset of this rule, you should have an alert for the guy who broke the build last. We are using the cache logs chain, so everyone can know him and log up from this. The next step is having a good branching strategy. So branches are usually depending on your process, the amount of your servers, but there are some things that I consider mandatory in getting the branching strategy. The first thing is always to get a master branch, meaning that your master branch is actually what's on production, and you should always be able to accept the production code. For the development, you need to use the development branch. So you shouldn't work on production. We all have to make some changes, but don't do it directly on production. You need to create ties. After deployment on production, it's really important to have ties in place. You should be able to revert to the latest stable version as soon as possible. If you have long-term features that you need to implement, it's a nice idea to have a feature branch out of the development, because by doing this, you basically protect yourself from releasing something to production that's not ready yet. And if a bug actually occurs on production, don't fix it directly there, create a hotfix branch. So you are sure you're not breaking the server more and more every time you fix the master branch. So here is a sample graph of what I'm talking about. I also usually have a release branch in place. Release is something like staging or pre-production. So as I said, we have the master branch. This is what's on production. These little things here are version 0.01, version 1, version 1.1 are actually the tags of this version. You can notice that they happen every time something gets deployed to production. The hotfix branch are created out of the master, and after that they should be back integrated to the development. Development branch, we are ready to discuss that. This is where the development happens. And if it's something more long-term, we have feature branches in place. So branches is the second most important step, and all build server have the capability to fetch from a different branch. So you can have continuous integration for your separate branches, for your separate servers, for your separate fields. The next thing is you always need to make sure dependencies right. That includes the front-end ones. And I'll explain what I mean in a little bit with front-end ones. Let's first talk about backend dependencies. So let's talk about Nugget. And not the delicious chicken with Nugget. I mean about batching. At Hedgehog, we actually adopted Nugget like a year ago, and we are experimenting with it. My colleague, Sean Mosby, actually dig into Nuggets and how to set your own private Nugget yesterday, so I'm not going to dig deeper into that. But you can always set private Nugget server. Most of the time they're cheap. MyGet, ProGet are cheap. Up there is the new section for cloud builds. It automatically checks out your Git code and builds it. It has an integrated Nugget server where you can import. Or if you're not fan of that, you can just use your custom code. Nugget feed is just a simple RSS feed. So it's really easy to write your own custom Nugget implementation. So front-end dependencies. Most of the front-end guys get actually neglected. And I was actually talking with Alan from Patient today, and we discussed how we make backend developers respect front-end developers. Because this is a huge issue in most cases. The guys, their technology actually went a really long path. They have their own package manager now, NPM, for installing some backend related things, let's say JavaScript backend. They have Bower for managing CSS dependencies, and they have their own task runners like Gulp and Grunt. Actually, Gulp and Grunt are not just front-end things. If you have seen Habitat, Habitat is actually using Gulp for executing continuous integration process. Gulp is a task runner. You can always have cookie from Visual Studio Task Runner. It's a new feature in 2015. Another important rule is that you should never version compile front-end resources, meaning CSS, JavaScript, etc. Most of the front-end guys are actually using some new technologies like CoffeeScript, they're using SAS or less, and they actually compile. There is a possibility for every build server to execute these tasks that compile. They're mostly Go programs. So I cannot say how many times I have actually seen production deployments failing just because someone accidentally mismerged minified CSS file. By recompiling your front-end assets every single time and building them like your C# code, you can make sure that your front-end is always up to date on your integration machine. The next step is testing. Testing, we cannot talk about continuous integration without mentioning testing. So the first step is actually making your site code testable. That's really important. We know that web forms is actually not really keen to unit testing, except in the case you're using some more abstract patterns like model to presenter, which are a little bit overhead for writing, but it helps make your code testable. So for all the new projects, you have heard this a lot during these 2 days in SUGCON, but for all the new projects, you should always start with MVP. The next step is you should always depend on abstractions and never on implementations. It's far more easier to test against your abstractions, and it's a lot difficult to test against your direct implementations. Related to this, consider using the dependency injection framework. Starting Cypher 8.1, it's really easy to do that. You just replace the default dependency with most of the modern dependency injection frameworks. Using Canorian for Cypher is almost mandatory for us. We at Hedgehog are using Plasma or Fortis, depending on the project and requirement, and they're doing a really great job. If you are still a fan of some Cypher project and you want to test it against your Cypher, there is a tool, there is a negative Cypher effectively, which actually mimics your, it spawns a Cypher instance out from that. So you can test against Cypher instance. So you should definitely get that book. It's expert excuses for not writing unit tests. I can see some guys already in Amazon right now on their phones. But if you plan not to write unit tests, you should definitely check that out. If you're still one of the few lost souls who want to write unit tests, there are tons of tools out there for .NET. The most famous one is probably NUnit. It works really nice. It's really easy to write unit tests with it. If you're lazy, Visual Studio has an integrated unit test, which you can always run. Another type of tests is actually integration tests. For C#, there is a tool called Selenium that has a C# wrapper, and you can run it from the normal test run. And for integration fields, Selenium is actually, that's mostly job of the QA engineers team, but you can still make some integration tests if you want. The takeaway is you need to write unit tests. And that's why it's especially for the guys who are already in the document. Another important step for a good continuous integration build is that you need to keep your code up to date. This can be achieved by multiple ways. Most popular ones are Razo, which can be scripted and can move your latest production content. Or if you're a fan of PowerShell, Cypher PowerShell extensions has there are 3 or 4 workflows on how to move content between different environments. So The next step is actually continuous deployment. We cannot talk about continuous integration in Cypher without mentioning continuous deployment process. Continuous deployment can be looked at as a three-step process, usually, in most of the cases. The first step is finding a way to serialize your items and bring them to source control. The second step is to build a package out of your serialized items. And the final step is deploying the package to your target environment. So let's start looking at the steps one by one. For serialization, there are tools out there like TDS, which is paid and commercial product, and Unicorn, which is free, and you can always use it. Especially for open source projects, it's really useful. There is also an option to write your custom solution, bringing back to source control. It's not that hard actually. You just need to invoke serialization API and get the results back to your process. For the next step, we have what's that sound? For building the package, again, we have the commercial TDS and we have Cypher Courier. Most of the people actually don't know that Courier comes with this beautiful file, which you can actually install on a build server, and you can invoke it build time, and it can build your package. So these are most of the two options, or again, everyone can write this control. For the third step is installing the package. That's one of the hardest steps actually, but there are tools, open source, of course, out there that can help you do that. Maybe the most popular one is Cypher Ship, written by Kevin Novi, who works for Cypher, and it allows you to automatically install packages posted via HTTP. So all build servers have an option to actually post a file to make a curl request, so you can post the file to your production environment and Cypher Ship will install. If you are a fan of file system operations, you can always use the Cypher package deploy. It creates a folder into your data, and it automatically installs all the packages that are put in there. Some notes. TDS can deploy items directly, usually, if your build server has access to the file system of the target instance. So you can use TDS to directly deploy. With Unicorn, again, if you deploy the items, you can deserialize them automatically without the need for packaging. Unicorn comes with an admin panel. It's like a Nugget package, and it adds an admin page for the ones who haven't used it. So you can just click, see everything. In case you are a fan of PowerShell, Unicorn also has PowerShell restrictions, which you can use to deserialize your items. And some advice for continuous integration, because we see this a lot when we're dealing with TDS approaches. You should always keep a minimum amount of content version in source control. Never version your entire content tree, don't try to sync it. There are other tools that will handle your content. Never deploy content of media items from car environment. By car environment, I mean production. Production content items shouldn't be touched by your build process, ever. This is content data area. You should set up something like a startup, but you should always migrate to somehow else. Never deploy directly from the integration process. Always backup the database before deploying database. Cypher doesn't have a nice way to actually revert changes, so this is somehow mandatory. You need to create a backup. And you can actually create backups by using PowerShell. Scripting is a huge part of any continuous integration deployment process, so you need to embrace scripting. PowerShell is not that hard. You can actually use the C# API inside if you want to write C# code. So invest some time to learn PowerShell. I've done that 1 year ago, and everything is much more simple now when you think about repetitive processes. So it allows you to script common tasks like DB and website backups. You can actually execute the remote PowerShells and backup your databases before you build Apache changes. You can also script common sidecar tasks like publishing items, doing things like this with sidecar PowerShell extensions. They are really useful. And they actually, the guys who build this, build an API on top of PowerShell and on top of sidecar. So we get additional sidecar features with it. So we're almost at the end, and we should answer one very important question. Should we deploy on production? Should we do continuous deployment on production? And the answer is actually I don't really know. It really depends on your case. If you're feeling safe enough to deploy to production, you should do it. Otherwise, you shouldn't. If you have a good backup process in place, you can deploy to production. Otherwise, don't do it. Or you can basically execute some of the steps, not all. So let's see my perfect production build scenario. So the first step is clean code checkout, meaning that the whole code repository on the build server will be deleted and it will be taken off of console control. By doing this, you make sure that you don't leave anything behind, because sometimes when you delete files, source control systems might not handle and understand that correctly. Second step is restoring the NuGet packages. As we said, use NuGet for everything, including side-forward dependencies. After that, you should restore and rectify your front-end assets. So it is going to be easier for your front-end guys to check if something was actually missing. After that, you should run unit tests on your code. If you're running integration tests in production, it's actually too late for an integration test on production. They should have been executed in lower environments. The production build should be fast and not slow. You should, I usually automate backups with PowerShell and execute the backups remotely. After that, the next steps are pretty straightforward. Building CN CD packages, separate ones, because they have different configs, so they have different transformers. The final step is deploying the installed package. This can be a manual process. You can just drop your package somewhere in your data folder, and you can just take it from there and install, or you can automatically install it with set or set. Any questions? No? Okay. Thanks for your attention.